In the annals of technological history, the year 1971 witnessed the birth of a revolution. It was the year a small, unassuming silicon chip, no larger than a fingernail, emerged from the nascent world of integrated circuits. This chip, the Intel 4004, was not the first microprocessor, as is often mistakenly claimed. However, it was the first commercially available single-chip central processing unit, a distinction that would forever alter the course of computing. This groundbreaking invention, conceived and brought to life within the bustling walls of Intel Corporation, marked a paradigm shift in technology. Before the 4004, computers were behemoths, occupying entire rooms and accessible only to a select few. The 4004, with its ability to perform all the functions of a computer's central logic unit on a single chip, promised to democratize computing power, making it accessible to the masses. The story of the 4004 is one of ingenuity, collaboration, and relentless pursuit of innovation. It is a testament to the power of human imagination and the transformative potential of technology. This is the story of the Intel 4004, the microprocessor that launched a revolution. The genesis of the 4004 can be traced back to a partnership between Intel, a fledgling semiconductor company at the time, and Busicom, a Japanese manufacturer of electronic calculators. In 1969, Busicom approached Intel with a proposal to develop a custom chipset for their new line of high-performance desktop calculators. Busicom's initial design called for a complex system of 7 chips, each dedicated to a specific function. This approach, while feasible, was deemed too cumbersome and expensive by Intel engineer Marcian Ted Hoff. Hoff, a visionary engineer with a knack for simplifying complex problems, believed there was a more elegant solution. Inspired by the architecture of mainframe computers, Hoff envisioned a radical departure from Busicom's original design. He proposed a 4-chip architecture with a central processing unit at its heart. This CPU, he argued, could be programmed to handle all the functions of the calculator, eliminating the need for multiple specialized chips. Hoff's proposal was a gamble. It required cramming the complex circuitry of a CPU onto a single chip, a feat deemed impossible by many at the time. However, Intel's management, recognizing the potential of Hoff's vision, decided to take the risk. Ted Hoff's proposal to reduce Busicom's calculator chipset from 7 chips to 4 was a pivotal moment in the development of the 4004. This simplification, driven by Hoff's belief in the power of general-purpose computing, laid the foundation for the microprocessor revolution. The 7-chip design, while common for complex electronics at the time, was inherently limited. Each chip was designed for a specific task, making the system inflexible and difficult to adapt. Hoff's vision, on the other hand, embraced the concept of a central processing unit that could be programmed to perform a wide range of functions. This shift towards a programmable CPU was revolutionary. It meant that the same chip could be used in a variety of devices, from calculators to traffic lights to industrial controllers, simply by changing the software instructions it executed. This flexibility and adaptability would become the defining characteristics of the microprocessor. Hoff's 4-chip architecture comprised a central processing unit, a read-only memory chip for storing the calculator's program, a random access memory chip for temporary data storage, and a shift register for input/output operations. This streamlined design not only reduced the chip count, but also simplified the overall design and manufacturing process. While Ted Hoff's vision laid the groundwork for the 4004, it was the engineering brilliance of Federico Fagin that brought the chip to life. Fagin, a young Italian engineer who had recently joined Intel, was tasked with leading the 4004 project in April 1970. Fagin faced a daunting challenge. Integrating the complex circuitry of a CPU onto a single chip was unprecedented at the time. Existing manufacturing processes and design methodologies were inadequate for the task. Undeterred, Fagin drew upon his expertise in semiconductor physics and his experience with a new technology called silicon gate technology. Silicon gate technology, developed by Fagin during his time at Fairchild Semiconductor, allowed for the creation of smaller and faster transistors, the fundamental building blocks of integrated circuits. Fagin's use of silicon gate technology proved crucial. It enabled him to pack an unprecedented number of transistors onto the 4004 chip, achieving the density and complexity required for a functional CPU. Moreover, silicon gate technology's improved transistor performance allowed the 4004 to operate at a clock speed of 740 kHz, significantly faster than any other integrated circuit at the time. In the early 1970s, a groundbreaking collaboration took place. Federico Fagin, Martian Ted Hoff, Masatoshi Shima, and Stanley Mazur joined forces at Intel. Together they embarked on a mission to create the world's first microprocessor. This ambitious project culminated in the Intel 4004, a chip that would revolutionize computing forever. The 4004 was not just a technological marvel, it was a testament to the power of teamwork and innovation. By integrating the functions of a computer's central processing unit onto a single chip, they laid the foundation for the digital age. The birth of the 4004 marked a pivotal moment in history, setting the stage for the rapid advancements in technology that followed. So let's dive into the era where 8-bit architecture began to shape the future of computing. It was a time when microprocessors became more accessible and started to find their way into homes and small businesses. This shift changed the landscape of technology forever, paving the way for the personal computer revolution. Moving forward, we encounter the rise of 16-bit and 32-bit architectures. These advancements brought about significant improvements in processing power and efficiency. They laid the groundwork for what we now consider modern computing, enabling more complex applications and operating systems to flourish. It's fascinating to think about how we went from simple calculators to the supercomputers that power today's most demanding tasks. This journey showcases the incredible leaps in technology and engineering, driven by relentless innovation and a desire to push the boundaries of what's possible. Looking ahead, the future of microprocessors is incredibly exciting. The innovations of the past have built a solid foundation for what's to come. As we continue to explore new frontiers in computing, we can only imagine the groundbreaking advancements that await us, fueled by the same spirit of creativity and determination that has driven progress for decades.